Alright, so this is 6.3. Today is going to be all about proving identities, and by proving identities we are going to prove things algebraically. This is where the first two sections have been leading up to, is being able to prove some equations. So today is going to get into some ugly equations, and it's going to take some algebraic know-how how to do this, and I'm not going to lie to you, it's going to be tough at first to be able to start recognizing identities. But once you get more and more familiar with them, you'll start to be able to pick up on different things pretty quickly. But again, really the best way to do this section is to actually practice, and to practice quite a bit. So the purposes, it says purposes with an S, but there's really only one purpose for today. That's to prove equations using identity, and to prove them using algebra. Again, not numbers, not graphically. We're just going to use algebra to prove some stuff using identities. So there's a few tips. I'm going to show you the tips now. I'll show you it again at the end. Hopefully these will help to stick in. So start with the most complicated side first. You'll have an equation that says prove this side equals this side. Start with the most complicated side and work that way down as soon as possible, or to as simplified as possible. And then sometimes you'll have to manipulate the other side. Other times you can just get there. That's kind of your goal. The nice thing with proving identities is that you know when you've done it right. If the left side equals the right side, you've done it. So that's the nice thing about this, is you have an end goal, you can figure out where you're going. So start with the most complicated side first. If you're given anything cotangent, tangent, cosecant, or secant, switch everything to sine and cosine. All your identities, I mean, you have tangent identities, but they're a lot more complicated than the other two. So try and switch to sine and cosine as quickly as possible. If you have multiple fractions, find a common denominator, so just so that you can add those fractions together. Usually that'll just make your life a whole lot easier. Use conjugates. I'll show you an example today what a conjugate is. This is essentially where you multiply by, if it's like x plus 1, the conjugate of x plus 1 would be x minus 1. So it's the same thing, except the negative version of it. Like I said, I'll show you an example of that during today's lesson. Do not combine more than one step per line. So do not try and do two things at once. It'll just make things a little bit more complicated. And if you have a second degree term, what I mean by that is something squared or something cubed, use the Pythagorean theorem or factor it, so you can factor stuff out. Do not use the square root. The square root is nowhere in any of the identities. It's really not going to help you. So do not use square roots when you're solving these. Use the Pythagoras theorem. If you don't remember what that is, check your formula sheet, or you'll see it a little bit today. So let's try some things. We're going to start off really easy. So you want to prove that cos x times cosecant x times tan x equals 1. And we're going to show restrictions for this once we've solved it. So the best way that I've ever seen with proofs in order to show this, when you're proving two sides of the equation equal each other, the best way to do this, set up a t-graph like this, set up your two sides of the equation on either side, and let's manipulate one side of the equation or the other. We cannot, and we are never going to, with proofs, move things to the other side of the equation. So part of mathematics is proofs. If you move on to anything math, physics related, you need to know how to do proofs. And what that looks like is never ever move things to the other side. So in this, you would not divide by cos x. You cannot do that. We're only manipulating one side at a time to try and get to equal both sides together. So for this one, we've got the left-hand side. Let's do with that. That's the most complicated. Let's get rid of everything, or at least convert everything into sine and cosine. Cosecant is 1 over sine, tan is sine over cos, and just like that, once we put everything into sine and cosine, look at how easy this is. Let's cross out the cosines because they divide out, cross out the sines, and voila, you end up with 1, which we wanted to prove. Left-hand side equals right-hand side. That is our whole goal with proofs, making sure that both sides of the equation equal each other. That's how easy the first example is. We'll start with that. Restrictions. Let's take a look at those. So again, remember with restrictions, anything in the denominator cannot equal 0. So in this case, restrictions, cosine x cannot equal 0, sine x cannot equal 0. If you remember from 6.1, this is our restriction. Again, you can do these separately if you wanted. You could figure out cosine x by itself, figure out sine x by itself if you wanted to, or the easy way, just combine them both together. Second example. Again, t-graph. Let's set this up. Both sides of my equation. Notice now it's not just equal to 1. We have something different. As always, let's start with our more complicated side, which in this case is the left-hand side. We've got a cosecant going on there. So what I did, multiplied it in. You could have expanded it or turned that into 1 over sine x first if you really wanted to. It doesn't really matter. But notice in the final answer, I want cosecant. So that's why I multiplied it first. If you did it the other way, it still works out. There's multiple paths you could actually get to a solution for this. Yeah. But let's cancel out the sine x. We notice there we get 1. So cosecant x plus 1. And left-hand side equals right-hand side. So we've solved it. So this is just using some manipulation. Again, some of you might have taken cosecant x and switched it to 1 over sine right away. And then multiplied it in, and then simplified it, and then converted it back, and that's okay. This takes practice, and you might not get the quickest solution. You might do multiple things sometimes, and that's okay. You might do something, you might undo it again later, and it's just about trying things. Really with this unit, and that's why lots of students struggle with this, you just need to try something. You might not know where you're going, give it a try. Restrictions. So again, anything in the denominator cannot equal 0. In this case, it's just sine x cannot equal to 0. There's your restriction. Another example. Okay, a little bit more complicated. We're just getting more and more complicated as we go along. So we've got secant squared x on the left. We've got 1 plus tan squared x on the right. We can figure out which one we want to manipulate. So the right-hand side, let's work with that. Since there's a plus, it's slightly more complicated. Turn it into sine and cosine. So tan squared x equals sine squared x over cos squared x. And since we have a fraction and we have a 1, and you notice the left-hand term is only a single term, there's no plus in there, we need to try and get rid of that plus. And the way to get rid of a plus is to combine these two things together. The only way to combine these is if we have a common denominator. Remember, that was one of the tips I said. If you're combining two different things, we want to get a common denominator. So 1 is cos squared x over cos squared x. This is just turning that into a fraction. My denominators are the same, so I can combine these two things together. If you look at your, which identity is it? I don't remember, but I think it's Pythagorean, if I remember correctly. Cos squared x plus sine squared x, this equals 1. Ta-dum. And 1 over cos squared x, this is the definition of secant squared x. So there we go. My left-hand side equals the right-hand side. We're done. Let's look at restrictions. Again, look at the denominators. In this case, only cosine x cannot equal to 0. So here's our restriction for that. Again, we covered restrictions with this in 6.1. So if any of these restrictions were the pi over 2 plus pi times n, if that doesn't make sense, review your 6.1, because that's where that part's all explained. Now we got two fractions. Again, left-hand side equals right-hand side. Let's start manipulating. Both of these are about the same complications, so it doesn't really matter which side we start with. I'm going to start with the left. So with this, we've got a denominator of 1 plus cos theta. It's not x this time, it's theta. And you will notice on the right-hand side, my denominator only has a single term. So I want to try and get something with that. There's no tangents to get rid of, or cosecants, or secants with this. So what we're going to try is the conjugate. We're going to multiply by the conjugate. Remember, I told you that this is the definition of conjugate. So I'm going to take my denominator, the 1 plus cos theta, and I'm going to multiply by the conjugate of that. And you will notice, conveniently, on the right-hand side, my conjugate is actually in the numerator. So again, some of these little tricks will be things you'll pick up as you move along, and just recognize, oh, the conjugate of this is actually in the numerator. So the more you do this, the more you'll recognize those little, oh yeah, that shows I'm on the right track. But it just, again, practice, practice, practice. So let's multiply this out. Here's what we get. And taking a look at this, so in the denominator, this is equal to sine squared x, or sine squared theta. Again, this is one of the manipulations with the Pythagorean identity, is that denominator there. And up in the numerator, I can factor out the sine theta. So I multiplied it in, just to show you, you can also undo what you just did, because I can now factor out or cancel out from the top the sine theta and the squared with the sine theta at the bottom to get back to what I wanted in the end. So here, left-hand side equals right-hand side, we're good. Let's look at restrictions very quickly here. So we've got two things we need to deal with. I cannot have sine theta equals 0. That's the right-hand side of the equation. There's the restrictions with theta for that. I also cannot have cos theta equal -1. That's from the left-hand side of the equation. This occurs when you've got theta equals pi plus a full rotation. I also, because of my 1 minus cos squared theta, I also cannot have cos theta equal 1. Again, that's from the conjugate we got here. So theta cannot equal 2 pi n. Therefore, if I combine all those different restrictions together, this is what I'd get for the total. Next one, yep, they're getting more and more complicated. I told you this was coming. So here's the left-hand side, here's the right-hand side. I'm not going to speak all of that. You can see what it says, pause it, copy it, then we move from there. So obviously the left-hand side is more complicated here. So we're going to take this first term, multiply it by the denominator of the second, take the second term, multiply it by the denominator of the first, and you'll notice I'll have the same denominator now. If I multiply this out, my denominators are the exact same, and I haven't combined the top terms. I just wanted to show you what those fractions would look like first. I have the same denominators. Let's combine fractions first. Then we're going to multiply everything together. So I'm going to expand the sine x into each of the brackets. I'm going to multiply what's in the denominator. So I end up with this expression here. So these two actually end up canceling each other out. And on the top, if I combine the two sine x's on the top, I get 2 sine x. In the denominator, we're dealing with, again, the Pythagoras identity. So I'll end up with 2 sine x over cos squared x. There's not a whole lot of manipulation I can go from there. So I'm going to leave the left-hand side for now. I might end up, well, you can tell there's no space, so I'm not going to keep going on the left-hand side. But sometimes if you get stuck on one side, you can start working on the other side. So I know I said start with the most complicated side, see where you get. But if you're stuck, just work on the other side. That's another good strategy, is just keep trying one of the sides until you see where you get. So on the right-hand side, you'll see we have a double angle, sine 2x. So let's expand that out first and figure out what that is. And secant cubed x. There's no equation with cubes. So let's do 1 over cos cube x. We can cancel out one of the cosines. And look at that. We ended up with what is on the left-hand side. Like I said, if you're stuck on one side, switch to the other. That will really help you. Yep. Yeah, more complicated. So left-hand side, right-hand side. I don't even remember when I made this PowerPoint which side I started with, because both of these are pretty complicated, so it doesn't matter which side you go with first. I think I went left. Yeah, I went left. I found the double angle, the top left, expanded that out, and you'll notice with the denominator, it's a difference of squares. If that doesn't make sense, come talk to me. This is something that was taught a while ago. From here, what I can do on the top is I can factor out a cosine x. And you'll notice on the top, I now have a bracket that is the same as the denominator. So let's cancel that out. And I have made the left-hand side a little bit nicer. And you will notice, a good hint, showing you're on the right track, my denominator on the left is now the denominator on the right. So again, these are the kind of things that you'll start recognizing, oh yeah, okay, I'm on the right track because I have something similar to the other side. Sometimes you get that, sometimes you don't. Let's start working on the right-hand side. So what I got, I can factor out a cosine x on the top, and I end up with sine squared x plus cosine squared x in brackets. Pythagoras identity, that is just 1. And my two sides are equal to each other. So there you go. That is that identity proof on that one. Wasn't as bad as it actually looked at the beginning. Do I have more? Nope. Okay, so let's go over these tips that I told you before. Start with the more complicated side. It just works out that way. If you're stuck, switch to the other side. In general, you're going to change everything into sine and cosine. If you have multiple fractions, find common denominator. I showed you that one. It just makes it easier to have it as a single term. Use those conjugates. If you're ever stuck, multiply by the conjugates. That'll help you get somewhere with the Pythagoras identity. You can start working with that. Don't do more than one thing per step. And notice we never used a square root. Don't use any square roots. That won't help. And some common mistakes that you could see in this, so avoid stuff such as this. Cosine of 2x divided by 2 is not cosine x. You cannot divide by 2 because that 2x is inside the cosine. Just like if I had 2x in brackets all squared, you couldn't divide that by 2. It just doesn't work. Another thing is you cannot just take the square root of every term. So if I have sine x squared plus cos squared x equals 1, you cannot just get rid of the square roots. It does not work. And also recognizing a double angle or a 2 times a sine or a squared are 3 different things. So do not mistake each of those. Where the 2 is placed makes a big difference. So there you go. That is section 6.3. This is the one that really just needs practice. It takes a lot of practice to manipulate those equations, and you need to be comfortable with the fact that you don't know where you're going. Just try some things. You might try something, it doesn't work. Try again, doesn't work. You're stuck on one side, switch to the other. This is something that it's kind of like a puzzle that you need to solve. Maybe that's why I like it, because I like puzzles. So this just takes some practice. So that's section 6.3. All right, so the next dad joke, this one, I forget if my daughter laughed at this one, but I think this one's pretty funny. This one's a story one, so it's a good one. Okay, so there was these pirates. They were on a pirate ship. Their pirate ship sank. I don't know why. They just sank. And you've got a couple pirates are left on a life raft, and they're floating around in the water, and they're taking inventory of everything they have. So they try to see what they have to survive. And in one of the boxes, they found a lamp, and they're like, ooh, maybe this is a genie lamp. And so they rubbed the lamp and out popped a genie. And the genie said, congratulations, I will grant you 1 wish. And they said, 1 wish? Why not 3 wishes? And he's like, well, I'm a genie, I make the rules, whatever. Immediately, without thinking, one of the pirates says, I wish that the entire ocean would be made of chocolate milk. And so, poof, the genie disappeared and the entire ocean turned into chocolate milk. And they tried it, and it was the best chocolate milk that they've ever tasted. After they've had their fill of the chocolate milk, one of the other pirates hits the pirate who made the wish on the shoulder and is like, you idiot, now we'll have to pee inside the boat. Yep, it's a lot harder telling jokes without an audience right in front of me. Anyways, I'm pretty sure my daughter laughed at this because, again, it's a pee joke, so pee jokes, Thunderwear, those ones are just classic with kids. It's just hilarious. So there you go. There's another dad joke. I hope you enjoyed it. You can use it on your dads, see if they like it, although I don't think it would translate. Well, you could try translating it. I don't know. There you go. There's another dad joke for you.